All right, so I don't exactly know your questions, but sorry if you can see that you are muted thing. I'm proctoring a meeting right now, proctoring some students testing. Um, if you would like some help on the Unit 3 practice test, so I don't exactly know what your questions are, but the first problem, it says find the error in the problem, explain what went wrong, and then fix it and find the correct solution. So there's multiple steps here. My recommendation to you is that you do the problem first, so that way you can see what the error is. So when you're doing long division, you want to ask yourself, what do you need to multiply x by to get 2x cubed? And that would be 2x squared. So you'd write that number at the top, and then you would perform that multiplication down below. After you perform that multiplication, you will subtract, and then you'll bring down your next term. So now you would ask yourself, what do you need to multiply x by to get x squared? And you'd write that answer at the top. And then you would perform that multiplication. There's something in my way. 2x. And then you would subtract. Negative 3x minus 2x makes a negative 5x. And then we would bring down the next term here. So we have negative 5x minus 7. You're going to ask yourself one final time, what do you need to multiply x by to get a negative 5x? And that will be a negative 5. Then we will do that multiplication. So we'll have a negative 5x minus 10. And we subtract. Negative 7 minus a negative 10 makes a positive 3. So our remainder is 3 over x plus 2. Now, we just did the multiplication, so we have done the fix-it part. We need to explain what went wrong. So looking at my work compared to this work, this is the mistake, the final steps here. A negative 5x minus 5x would actually make a negative 10x. So this person, you would write this out in words. This person did not multiply by a negative 5. That also changed the remainder, because we got a different remainder because we used incorrect math. So we've now explained what went wrong, we fixed it, and the correct solution is right here. So that would be what you do for problem number 1. And we highlighted the error as well. We highlighted the error in this problem. So hopefully that answers any questions you might have had on problem 1. Again, I wasn't told what the questions were. On number 2, we have some of these x-intercepts here. It asks us to find the polynomial and write our answer in standard form. So to go from zeros to factors, we switch the sign. So if I have negative 3 as a 0, that means x plus 3 was the factor that gave me negative 3 as an answer. Because look at my work over here on the left. That gives me negative 3 as an answer. So this is what I get from my graph when I have a negative 3, a positive 1, and a negative 1. Now this is not in standard form, this is in factored form. So to factor, I'm going to multiply my first 2 terms together, and I'm going to FOIL them. So that means I'm going to multiply x times x to get x squared, x times negative 1, 3 times x, and 3 times negative 1. Adding my like terms together, I get x squared plus 2x minus 3. Now I didn't multiply all my factors together yet. I still have this x plus 1 left. So now I'm going to take everything in this first parenthesis and multiply it by everything in this second parenthesis. So x squared times x makes an x cubed. X squared times 1 makes an x squared. 2x times x makes a 2x squared. 2x times 1 makes a 2x. Negative 3 times x makes a negative 3x. And negative 3 times 1 makes a negative 3. So we're left with x cubed plus 3x squared, x squared plus 2x squared is 3x squared, minus x minus 3. So this would be your polynomial written in standard form with the highest exponent first and going down in descending order. So hopefully that helps. In number 2, I'm sorry if you hear people talking. I'm also proctoring ukulele club working right now. Alrighty, problem 3. What you're going to do for number 3 is you want to determine, what your zeros are of this graph. So in order to determine what your zeros are of this graph, you will be first, it's kind of counterintuitive, but you're actually first going to graph this on Desmos. That's going to allow you to actually see what this graph looks like. You could use your TI-84 calculator if you want, but it's easier for me right now to share my screen this way. So we have x cubed minus 3x squared minus x plus 3, x cubed minus 3x squared, what was it, minus x plus 3, I believe. So that's what our graph looks like. From our graph, we can see that we have 3 x-intercepts. So we have -1, we have +1, and we have 3. We need to show, where did that go? We need to show algebraically how to find the zeros because it's asking us to show our work, and we can't just say we graphed it on Desmos and then we copied the graph. Instead, I'm going to pick one of those zeros from Desmos. So Desmos told me that my graph crossed the x-axis at 3 in one of the instances. So I'm going to choose that value, and I'm going to do synthetic division with that value to algebraically prove that 3 is in fact a 0 in my graph. I don't need to change the sign here because 3 is the 0. The factor that gives me 3 is x minus 3. So doing this synthetic division, 3 times 0 is 0. Alrighty, we end up with a 0 as a remainder, which is perfect, a -1 as our constant, a 0 as our x, and a 1 as our x squared. So we're ending up with x squared minus 1 equals 0. Now this is a quadratic equation, and we want to find other zeros. So we have options. We could use the quadratic formula. We could use factoring. We could even use square roots, whichever one you are more comfortable with. Because it's not live right now, I don't know which one you would prefer. I can see that this factors into x plus 1 times x minus 1. So I'm going to choose the factoring method. And then using the zero product property, I'm going to get my other x values. So I've just now shown algebraically that the zeros of this graph occur when x is -1, when x is 1, and when x is 3. And even if you decided to do synthetic division with a different number, you would still get these 3 as answers. So we've found the zeros of the function and we've shown our work. So we've done part A. Part B asks us to graph the function, label the zeros, and explain the end behavior. So before I can explain the end behavior, I know what this graph looks like, but I also want you to be able to explain, looking at my first term here, my first term is x cubed. The degree here is odd, and the number in front of the x squared is positive. So when we have an odd degree polynomial and a positive a value, our end behavior goes up in the positive direction and down in the negative direction. I'm going to now use that information to graph my polynomial. So this is a nice sketch of what the graph looks like. You might even notice that I made sure that I crossed the y-axis here at 3 because 3 would be my y-intercept. If I plugged in 0 for x's here, I would get 3 as a y-intercept. So that's a nice sketch of my graph. So I graph the function. I want to label my zeros. So my zero is happening at -1, 1, and 3. And I put dots there to prove that, hey, I'm saying those are exact points. And then explain the end behavior. So using mathematical notation, I'm going to say as x approaches infinity, that means as x gets bigger and bigger, I'm looking at this part of my graph, y also gets bigger and bigger. So y also approaches infinity. Then I'm going to look at my other side of the graph. The mathematical notation for that side of the graph is as x approaches negative infinity, as x gets smaller and smaller. Because that arrow goes down, that means y also gets smaller and smaller. So y also approaches negative infinity. You do earn extra credit if you clearly label and define the local maximum and minimum points. That's actually not something that I taught you in class this year. That's why it's extra credit. Because of the pandemic, we've been cutting material from the lessons. So if you have interest in figuring out to find the maximum and minimum, I will encourage you to look at other resources that are available to you. So hopefully this explanation here helps you with your practice test. Like I said, I didn't receive any questions, so I just kind of went over every question, answering what I've had other students ask me so far. So hopefully this was helpful. I apologize that I was not available to tutor you when you wanted tutored. Please email me if you have other questions. I am available Thursday morning before school if that works.